Okay, hello. All right. Time to do stuff. So we got stuff to do. What do we do? I guess I should make a to-do list. Where are the notes? Oh, it's just two people's games gonna compile. Shit. All right, now what? Kind of everything. I did this, I think. Text walls, did that. Didn't do that. Did that. Did that. All right, this is all that's left. Let's do it. Am I even streaming? I guess so. Okay. Time to do stuff. So first thing, bounding spheres. This is my current plan. It's gonna be fucking hard. Okay. Bounding sphere. Calculate bounding sphere. Took milliseconds. Okay. So this is not technically right in a lot of ways. Okay, I think before this. Ah, shit. Okay, before this, I think I have to maybe finish serializing everything, maybe. Probably. I don't know how to serialize an instance model. Oh. My Chatterino is broken. The fuck? I can't even log into Twitch. Hey. Hey, real Pattinson. How's it going? Yeah, I couldn't see chat. There we go. I can now. Are you doing? Got anything to complain about? Yes. Publishers. Marketing. I hate it. That's all. Okay, I think I fixed my Twitch. Alright, now let's keep doing stuff. Okay. So... first instanced models. How do I do this? Just make a good game and it will become popular easy. I do not actually think that's true. I used to think that's true. Maybe I'm being overly pessimistic. I don't think that's true anymore. So many examples. Are those examples multiplayer? The thing is though, you also have like survivorship bias, right? If there's good games that aren't popular and don't take off, you won't have heard about them. Name a game that proves your opinion. A good game... maybe. Okay. I do know one. I don't know if I can find it. I'm also not going to look very long because I have to work, so... I try in a quick search in my library. I can't find it. So I will not tell you. There is a multiplayer game that was like arena based and it was a Western style shooter. It was actually good, but it was super dead. Not MOBA? Not MOBA. I guess the thing I'm talking about would qualify as MOBA. Why not MOBA? Just full of frags? No. But I don't remember. Anyways, time to work. How the fuck do I do this? Create instanced model. Okay. Actually, this is okay. If you're creating an instance model this way, it's not a big deal. Yeah, that is true. Maybe in level manager. Uh-oh. Okay, this one's fine. Probably. I still do need it in the level manager though. I guess this. Renewable instances, okay. So I guess what we do here is when you... Fuck, I don't know, man. Let me go look at this. Yeah, that's not okay. Should upload true. Geometry instances. Wanna see what I made recently? Sure. Or false. So, what you working on today? Optimizations. The main thing I'll do today is a really complicated sphere bounding algorithm. I started on it last night. I'm not done yet. Sphere bounds is probably better than object-oriented bounds. And I plan to use probably both. But yeah, sure. So I think I just have to have an additional step here. Nope, I don't fucking know. This is hard, man. I do basically need something like this, right? And then you say instances AABB sphere and then bounding sphere. This. This is tricky. Maybe in the get vertices method, I can make it work here. Because all this does is take the geometry and the instances. So this thing could, in fact, right? It literally is only geometry and instances only. Yeah. So this thing could, in fact, be a geometry and instances. And then I can use it for everything. So either get vertices this way, geometry, instances, which is a matrix 4. Matrix 4 though. Yep. Yep. I don't have to have that be a pointer. Okay, Okay, that should basically probably work. So now I can get the vertices this way. Where the fuck was I? Okay. And now you just use this thing using geometry and wrapper, no. And that's fine, yeah. Wrapper geometry and wrapper instances transform. Call that a transform. Iterator instance. Okay, that's a separate thing. This should work. And then it goes to the vertex count, which is right. Gets your position, which is your vertices I times stride. And then transforms that with your model matrix. And then geometry vertex count times instance index. Also correct, plus I, also correct. Okay, this looks right. Okay, so now I can use this shit way up here. So this guy will just return a create instanced model of geometry. This one, I'm not sure what to do. Actually, yes, I do. I know what to do. You just get the vertices and you pass them to, okay. But then, wait. Bounding sphere. Bounding, what should this be called? Like bounding objects? Bounding shapes? Because I have bounding sphere, right? So then I'm going to have calculate ABB. Also just from a vertex iterator. Okay, that will work. And I should just copy this code as well, I think. Calculate ABB. Where the fuck? You... Don't need any of that for vertex and the iterator. Blah, blah, blah. It's just this. If you haven't yet set the thing to the thing. Otherwise, set the thing to the other thing. And return. Way infinitely massively easier than bounding sphere. Okay, now complicated bounding sphere Weltzler algorithm. It's gonna take fucking forever to run. But anyways, we have to keep doing this. Calculate ABB, return, calculate ABB of get vertices geometry. Just like that. Okay, that should work. Why was I doing this? I guess here, yeah. Okay, so now you create an instance model with geometry, instances, calculate ABB. Oh wait, I need the vertex iterator. Get vertices of geometry and instances, which might not work because this is a pointer, but we'll see. Calculate sphere of vertex iterator and should upload. Okay. So this function accepts these things pre-made, right? So I'll just do it like this. Okay. should work. And now, finally, in level editor thingy, load a level model with, wait a minute. How does it know? When does it accept instances? Renderable. Oh, it's from... Oh, you give it the renderable. Okay, we're learning. Let's go look at renderable. So that's what I have to modify here. Renderable instances. You might have an ABB. You might have a bounding sphere. This is gonna change my level load time to be massively longer when it's not, when you're reloading, which is a lot during development. We'll see. We will see. Okay, so for instance models only, you create a geometry. Wait, what the fuck? Oh, it's copying it. That's copying it. Okay, that's fine. So after you add all the instances into renderable instances, which I'm pretty certain is a matrix 4 array. Yep. Then we will say renderable ABB is calculate ABB. Get vertices of copy geometry of the geometry and the renderable instances. And then the bounding sphere is calculate bounding sphere of the get the same vertex. Okay, so also then vertex iterator. Okay. Fuck. So I have this data now. When you're loading the level, I do not care about this. I do not care about this for non-instance models. Yep. So when you create your instance model, you also have to provide a renderable ABB and a renderable bounding sphere. I think I should. Yeah, we'll see. I should probably add some warning to the bounding sphere function that basically says this should never be called ever. Probably. But let's keep going. Well, that's it. That should do it. Okay, that should do it. I guess I work on the bounding sphere function now. Let's get this on. And skip this on. Alright, bounding sphere is gonna be... I want to see what this is, to be honest. I'm relying on this, aren't I? Oh no, I'm not anymore. Alright. So this is supposed to be a recursive function. And I made it not recursive, and I'm pretty fucking certain I did it wrong. So I'm gonna try and make it not recursive, but stack based. Oh, this could become gigantic. kind of wish temporary allocator, you could free from it, but you had to free in the order you assigned. I think that would be cool. Well, anyways, I think you do this for while spheres count as greater than 0. Is this helpful at all? We'll figure this out as we go. This is your sphere. If the sphere contains the thing, you're always going to be operating off of 0, aren't you? Isn't that how stack works? I don't know. It'll work for me though. You can use suballocator. Wait, what's your question? Are you talking about? Are you just asking it in Jai in general? Jai has allocators. You can use different allocators. So yes, it's built into the language. So the default allocator is also just an allocator that you just happen to be using. This will work, in fact, actually. But this is a stack, right? So if I want to do this, and the stack will probably be like 50,000 big. If I want to do this optimally, it would actually, I would use a block allocator. Because it's set up, it's very clever. It's set up to work with stacks because it's blocks of things, and when one gets emptied, it goes to the back. So it reuses blocks. I mean, you use suballocator that would use temp allocator under the hood so you can free from the temp allocator. Oh. Yeah, I mean, kind of what you're suggesting. The temporary allocator isn't very complicated, and I could just make my own. But it's not that important. I just want it to be a language feature, because there's no reason you can't do that. Because the purpose of the temporary allocator is to be fast. So you allocate, and it kind of just like pushes the number forward, the pointer. But in the same logic, you could deallocate, and it keeps track of the, you know, allocation stack and just goes back. It would work. So I don't want to do it, but it could just happen. But yeah, I could do that. So, okay, let's do it correctly here, right? So, defer free spheres. How do you free a block allocator? This is my own code, I don't remember. Uh-oh, you can't. So, in order to free it, you would go through, you have an allocator. I forgot about that. Oh, I'm sure I'm not using the allocator right. Oh well. Effectively, the only thing you have to do is free the blocks, which is just a list of blocks, and then each block is just a list of entries. That's all you have to free. Okay. It's memory, and then entries. And then entries. So array free block entries, array free block memory. That's all. I think. For every block, free entries, and then free memory. With your allocator, that's important. This is stupid looking. Isn't this how you do it? Oh, you don't have to say allocator equals. All right, that should do it, I guess. So defer free spheres. Okay, now we have this. So now though, so the way to get it optimized as a stack thing is you pop it out like that. And then I guess you release it. And then the important thing is when you create a new one, you add it at the end. When you get first, I guess I should also have pop first. Pop. Would pop imply it's coming out of the beginning? I guess it's not opinionated about that. Pop first. And that one should not be a pointer. Okay, so this is gonna do you need to reset count on allocator? On the temporary allocator, yes. Is that what you mean? On temporary allocator, yes. You reset it whatever logically makes sense, like every frame. Yep. Release. So this is the kind of stupid way to do it, though. This thing is going through this stuff. Yeah. But it's not that slow. And also, it returns the index when you iterate through. It returns the actual index. Yeah. That's not... So then you can free based on that, and it's like instant. Yeah. Free empty. Oh. Not true. Okay. So we will do the same thing. Not a pointer. Entry index. Okay, so for the very first one we find, it's presumed to be not a pointer. Yeah, so now it's in memory. So now we release allocator entry index, and that should just do it. That should just work. Yeah. And then you can just return entry. Okay, that's all. That's all you do. That should work. Spheres is pop first. Spheres. And that count thing is still valid. Okay, continue. Then here's the bit where this is not accurate. We will claim at the end of spheres a new sphere to make it a stack thing, right? I think. I fucking hope. And then after you claim end, break. So then it stops this whole thing, restarts with a new sphere. This sphere is donezo. Yep. Can I do this faster? There's create sphere. Okay, so this one is wrong, right? This one, before I was doing it, I was finding the best sphere of the four potential. I'm totally like fucking this algorithm up. Like, this is not accurate at all anymore. Because I don't understand how this works, actually. It doesn't make any sense to me, and I think the example code I found might be wrong. This recursive thing makes no fucking sense. It's just this also. This is my code. This is the entire Wellesley sphere algorithm. Recursively. This is my version. So I think to do it correctly, I have to attempt all of these spheres. The thing is that even accurate? because I don't fucking know. The thing is, this could very, very easily be not accurate, because you could find a sphere that's gigantic. So here's the problem. You could find a sphere that's gigantic. So what this is doing is it's creating a sphere based on 4 points, right? And it's not just that the sphere contains these 4 points, it's that these 4 points lie on the edge of the sphere. I am pretty sure. Yeah, and I think. And so I'm pretty sure, yeah. What doesn't that mean it's always going to be not accurate? I don't fucking know, man. No, it could be accurate because this also tests the case of 3 supports. Okay, so hang on. The problem with my algorithm then is that when once the algorithm gets to 3 support points, it never goes back down to 4. That just doesn't seem right. So anyways, that's almost definitely not right, actually. Where is real-time collision detection something something? I don't have it here. There it is. This is where I got the algorithm. Which this book is typically like totally accurate about everything. So let's go find spheres. You not be so zoomed in? Whatever. Okay, so there's a bunch of shit here to get through. Okay, I think I don't want it this zoomed in. Guess I won't. I guess I... Oh, there we go. So, for the bounding spheres, it gives you algorithms to do it. Yeah, for the bounding spheres, it gives you algorithms to do it in order of increasing accuracy and increasing, you know, slowness. So all of these, I want it, the way my code typically works is that the expensive stuff I just serialize at the start. None of this matters to me. So none of this doesn't matter either, I think. Oh, I could make my algorithm work though. So I don't, okay. I could make my algorithm work, ignoring what it's actually supposed to do. So this is the part where it matters, right? A sphere is defined by 4 non-coplanar points, thus the brute force algorithm computing the minimum bounding sphere for the set of points is considered all possible combinations of 4. So it's like, yeah, into the power 5. I guess. Computing the smallest sphere from these points and keeping the sphere if it contains all other points. The kept sphere with the smallest radius is then the minimum bounding sphere. I mean, I keep thinking. Fortunately, the problem with computing the minimum bounding sphere for a set of points is well studied. A randomized algorithm. Okay, so yeah, also, they say it's supposed to be randomized, and this one is not. But I know why it is. I don't want to do it randomized, so I'm going to go off on my own and do my own thing, I guess. So I have to understand why this works. Assume minimum bounding sphere has been computed for a set of points P. If the new point Q is added to P, then only if Q lies outside S does S need to be recomputed. Okay. It's not typical to see a Q must lie on the boundary. That's the part I'm not sure about. So here's the problem. Let's do it in 2D. You have your sphere, right? So 2D, 3 points. Now, sphere guy. Perfect sphere. Okay, so now here is the problem. You add a new point here. What will happen? Okay, let me actually do accurate spheres. Hang on. Damn it, whatever, good enough. No, it's not. Please fucking... Okay, good. We add a new point here. Now what happens? This is the problem. I guess it does just abandon that one because this is the only... But yeah, this is the... Okay, so see, here is the problem, right? So we have multiple choices now. If we go here, we have this choice. But then also, we have some gigantic choice of like... Fuck, I hate that I can't draw the other way. If we take these 2 points... That's not even accurate yet. You can also do one with these 3 points. So let me do that one first. You can do one with these 3 points. See, that's technically still a valid sphere. Okay. So I think the way I'm doing it might actually work without even a stack, which is crazy. Although I'm very, very fucking skeptical. Because what I would do is take these four potential spheres it's found. Yeah, I'd take these 4 potential spheres it's found, and then I just choose the one with the smallest radius and keep going. But here, okay, no, actually that's not totally right, because here's the problem, is then in the future, you could find another dot here. And then what? If you chose the smaller sphere up to this point, you're not going to be allowed to go back and check these 2. So you would only be able to do these, and now it's not a valid sphere. Basically. Potentially. No, actually that's technically not true, actually. Because the existing sphere already runs through all 3 points, all 4 points. Yeah, so it's 1, 2, 3, it's these ones. So then you would just find another one with any of these 3 permutation combination of points that goes through everything. And inherently, because it's growing, doesn't that mean it will automatically increase the scale? I'm not sure. Fucking must, right? I think there's a situation where it could potentially not. Because if you actually put a point like a gigantically far out, then you're gonna have a giga giant sphere. And the two points it has to go through is 1, 2, and that one. So it's gonna be too big. Yeah, it is gonna be like this, right? So then I guess I cannot actually make a perfect sphere, whatever. God damn it. Good enough. So it'd be like that, and now this is technically still valid because that was not previously a support point. However, this sphere it's created to bound it is not valid. Okay. So not okay. Not an okay solution. Well, that's tough. So that implies to me the real solution is I do have to do all permutations of all spheres and keep track of it in a stacky thing. So this algorithm that he gave me, I still don't understand it, really. Because it's so fucking weird. Like, I don't understand what happens in this situation. It just keeps, it goes, so basically it's recursive, right? It goes all the way down to index 0. It gets the smallest sphere at index 0, which is nothing, and then it goes back up to index 1, creates a new sphere of radius 0, goes back up to index 2, creates a new sphere of radius, like, distance over 2, and then, now the logic starts. So then, as it keeps going back up, if it's valid, it just keeps this sphere forever, okay? Here's the problem with this algorithm, why I think it doesn't work. Even though this is in the book that so far has never been wrong in the like years I've been using it. The problem is, if it doesn't fit inside this sphere, and like obviously the first couple won't because they're basically random shit spheres, it adds a new support point. It adds a new support point and then goes back down. Okay, wait, this might be why it works. It goes back down 1? Oh, well, that is why it works. It goes back down to 1, not to 0. That's why it works. And then it goes back down 1 point. Now it keeps going, well, then it keeps going back down to 0 with the new support point. So I guess effectively it does go back down to 0. I'm gonna skip this one. And then it goes back up. So it goes back down to 0 with the new support points, and from 0 it starts going back up. Maybe I'm thinking about this wrong, I don't know. And then again, as it's going back up, if it found another point that's not inside the sphere, it adds a new support point and restarts back at 0. So my problem with this is that by the time it seems to me totally, completely possible to come out with a sphere that has like 30 support points, in which case it never even decreases the number of support points, so effectively it never returns, right? Like, this just doesn't seem right to me. It really, really, really doesn't. But I must just not be understanding it. Pick a point at random, yeah. I should probably just trust this guy. I could just literally just implement this stack algorithm not in a stack. Like recursive algorithm in a stack, I mean. Iteratively. I could just do the exact algorithm. It's just my problem with this is I don't understand it. Recursion is complicated. The problem also is this thing, their algorithm is, this is what I really also want to avoid. If I were to make this, it's hard to convert this recursive algorithm to an iterative algorithm because they're using recursion to iterate through the stack, which is weird as fuck. But I think it's necessary. Let's see if I could understand exactly how this algorithm is actually working. I could do it myself, I'm almost sure. Like how... The implication of this is that it can never get above 4 support points, but that just doesn't make any fucking sense to me. Like when you get here, you find a smallest sphere. This could have 4 support points already. If... Show yourself then. What are you talking about? If, when you get down to 4 support points, he knows. I have no clue what you're talking about. When you, if you don't find something inside that sphere, you go back down again, right? You're already at 4 support points. This will absolutely happen. You're gonna increase your number of support points to 5. Okay, so now at this point you have 5 support points. Bro. This can't possibly work, man. Capucci man. I don't know, I still feel like this can't possibly work. So that's the problem. Let's just try to do shit. My other problem with this algorithm actually, by the way, what's a good example? Yeah, here's a good example. I think, I could be wrong. Actually, I should just test this right now. Wait. I made these methods last night that I'm not sure are right. There's a lot of moving parts to create spheres from 1, 2, 3, and 4 points. I think this is how you do it. However, okay, here's the problem. If you have a sphere with 1, 2, 3 points, almost for sure this is what's going to happen. Which I think this is right. So the actual sphere you would want from these guys is this. It's this. Something like that. And so it contains that one, but what you're actually going to get back from this algorithm is this. Okay, not that. Not that either. This is going to be the sphere it gives you back, something like that, because it has to lie on the point. So I guess that's the reason the recursion is necessary, right? So even if this is 0, 1, 2, you have to have a way. So first it will come out with this guy. And then that one doesn't fit here. So okay, here's the other problem then. You have to now consider every permutation of these. Okay, that's the part I'm missing maybe. Which will be where this is one of them, and this other one is one of them. Alright, let's try that. Let's try. How the fuck do you do this? How do you do this? That's also, oh, that makes sense then. When this determinant guy, maybe it doesn't make sense. This method to creating them from determinants doesn't always work. Hello again. Hey, Elemental Magic's card game. I remember you. Because when you have one, this is what the weird part, in 3D space, when you have everything on a plane, technically, this is still a valid sphere, but it doesn't know it. I don't know why. It's like this, right? How goes the Jai? Pretty good. Doing math stuff today. So this is a valid sphere. It returns 0 because the determinant of the T matrix is 0. So I don't know what to do. That's a problem all on its own, actually. Oh, actually, well, hang on. I wonder, yeah, so even if you do this, though, well, it'll still work. Because I'm also going to consider... Fuck. It'll still work, it's just shit. I'm also going to consider now, this is my new logic, all permutations, so this, or whatever the fuck. Like, okay, this. This is one of them, but this is one permutation. So that'll be valid, even if it can't find the 4-point permutation. If they're all on the same plane... If they're all on the same plane, then it should be covered by either the 3 or 2-point version. So that should work now. Let's keep going. Okay. Claim at the end. If you don't yet have points, 1 single point. I think I'm just gonna ignore this one for permutations. No, yeah, no. Wait, what the fuck do you do? Because the implication of this, oh god. I think I'm just coming up with an n to the power of 4 algorithm, actually, now that I'm thinking about it, right? Because if I'm doing all permutations, every time a point doesn't fit inside a sphere, it's just a slightly optimized n to the power of 4 algorithm, isn't it? Bro, fucking kill me. Am I right? Am I? Because you can't even start... No, you can start with a support point. Yeah, because it'll eventually assume permutations, so... I think I can leave this one as it is. And I think I can leave this one as it is, because obviously you don't want 1 support point or 0. This one is not okay. This one is... You have to consider these... Oh, fuck. How do I want to do this? This is gonna explode out of control, is it not? I don't know. I think I could maybe even not have a stack. I'm back to that idea. If I don't have a stack though, I have to do this validity check. I don't fucking know, man. Let's keep writing code. We'll see what happens eventually. So here's the biggest problem though. When you get to stuff like this, oh, this is an even bigger problem. Oh my fucking god. boy. 0, 1, 0, 2, 0, 3. Okay, wait, this is starting to seem ridiculous, no? I don't know. For every single point it finds that's not valid in the sphere, it's adding like a shit ton of points. Uh-oh. This doesn't seem right. But their algorithm is adding a shit ton of points. If you have like 4,000 points, this thing is effectively adding like 4,000 spheres, and every time it goes back up and finds it not inside it, it adds another like 0, 2 index count spheres. I don't know if I'm really that wrong. What I could do though is verify this new sphere I'm creating is valid before I add it for all the existing points. That would be okay to do? No? I don't know. Because now I have new support points. So then I have to go back to the beginning and then maybe if it doesn't fit, then no, it's not valid to do. Fucking kill me. Fucking kill me. Okay, well. This isn't even out. It's I don't even know. An entry, okay? That's our struct. Which has a sphere. And an entry has a... I do kind of need to function like this. It has this, and then it has support points, which is for support count. I need to understand this algorithm better, I swear to God. And then you don't care. You're gonna start back at 0 no matter what. I'm pretty sure. But then, so this largest distance thing, no, that's not it. Yeah, that's not valid anymore. Okay. And I don't care about the validity check. That's part of the recursion. I think it has to be part of the recursion. God damn it. This algorithm is going to take like a day to fucking run per geometry. I feel like, man, god damn, isn't it? This is going to be insane. I think. Look at this shit. And now here we go. 0, 1, 2. What about 3? Oh no. This can't be right. 0, 1, 2, 0, 2, 0, 1, 3. Zero, 1, 2, 0, 1, 3, 0, 2, 3. How was I want to follow the same pattern. How was I doing this? I was changing the last one only. Wait, no, I wasn't. I was keeping the early ones the same as long as I could. Okay, that's how I'm doing it. Got it. So 1, 1, 2, 2, 2, 2, 3. Is that really fucking right? I just have to have all permutations. That's all. So 0, 1, 2, 0, 1, 3, 0, 2, 3, and 1, 2, 3. That's it. Pretty sure. Although the numbers don't look right. I guess it is. Yeah, I guess it is. Alright, and then 0, 1, 2, 3. Okay. Oh boy. The fucking create sphere algorithm is even slow, by the way. God. And then I also have to consider I for this one. Oh boy. Oh wait, this isn't how it works though. It's uh-oh. It's even harder than this. I should have like a create sphere algorithm from support points, but like supports. Okay, I can do that, yeah. And I can have it be in and vector 3. This will work, and then it'll give you back an entry. I'll call it a sphere entry, at least that's something. Return. Create a, uh-oh. If n is 0. Wait, yeah. Okay, that's how that works. Is it? It's like this, right? I think so. I think I have to do it again. If n is 1. M supports 0. Two. 3. 2, I mean, but 3 count. This is why my game takes so long to make. Okay. Wait, no. Wait, what? 1, 2, 3, 4. Okay. Otherwise, assert. Also, actually, that can compile time. Wait, no, wait, what? No, it can't be. It's never gonna happen, actually. Because it's compile time. Okay. So anyways, create your sphere, and then add the support points, and give it the right number, and that's your new entry. So we'll create our sphere. So the thing is, I guess I should just call it, I don't even fucking... I wish you could get the count back out of a spread operator as compile time, but it's really hard. You can, but it's really fucking hard. Ugh. Okay, so we'll just do this. Oh my god, there's so many. This feels so bad. This can't possibly be right, man. I don't know, man. I'm so conflicted about this. Wait, I did something very wrong. What did I do so wrong? Oh, create sphere. Create sphere takes this point array. I guess this will work for compiling, probably not for running. Okay, now the one where I'm now omega fucked. How do I do this? That one, another permutation, that one, and then another permutation, that one. And now the 3 permutations. 0, 1, 2, 3, 0, 1, 3, 0, 1 point. I wonder if there's like a generic way in Jai that you could convert a recursive function into being not recursive. I bet there fucking is. Wait a minute, maybe I should do that. That might be fucking genius. I could Jaiify it and do some compile time stuff. I bet I can. Wait a minute. Okay, I'll think about that. I guess that would take away some control though. Anyways, let's keep doing this for now. Am I really doing this right? 0, 5 of them, and then this one should have more than that, no? 1, 2, 3. 1, 0, 1, 2, 0, 1, 3, 0, 1 I, 0, 2, 3, 0, 2 I, 1, 2, 3, 1, 2, I. Pretty sure I'm doing it right. Maybe. Now this one has permutations. See, okay, wait, maybe I'm doing it wrong. So what about like 3I2? So it'd be 2, 3. Yeah, I did do that one. 2, 3I. And then 3. Okay, I did that one. So 0, 1, 2, 3, I. Wait a minute. This is going to be infinite, right? Because I'm adding... I don't know. Because I'm adding back the same ones that are being tested, which is... No, I'm not. I'm updating support points. Okay. Wait, so let's not do that. Let's not ever modify support points. That doesn't make sense. Does not make sense anymore. There we go. So if there are 0, it's just points I. Okay, things changed a little bit. If there's 1, it's 0I, that's it. Okay. If there's 2, we don't want to call back the same one. Zero I, and then 1I. This is all we consider. No, wait, that's not true. If there's 1... Do I actually really want to call 0 and I also in this situation for this guy? No, because I know the 0 size is never valid. Okay. So this one is 0I, 1I, and that's it. No, and 0, 1I. Those are the only new ones. Because I don't... It's already a 2. Okay, so here I start falling back to 2. Which is 0, 1, 0, 2, 1, 2, and then 0I, and then 1I. No more of those, actually. This is all permutations. No, it's not. 2I. So now we have 0, 1, 0, 2, 0I, 1, 2, 1I, and 2I. That sounds right. Okay, we're getting there. I don't want to recheck this same one. Yeah, don't. Zero. Hey, just read the part of the Wikipedia of the algorithm, and it's very good to understand, and it's very good to understand the recursive part. What do you mean very good? What does that mean? Very useful? Zero, 1I, 0, 2I, 1, 2I. That's all. Now, last one. 0, 1, 2, I. Wait, that's it. Okay. Now these... We'll start here, because this isn't even right, though. 3, 3, 3, and a doing it slightly wrong. Supports 2, 3, I. So 0, 1, 2, 3, I, 1, 2, 3, I, 2, 3, I, and 3, I. Okay, now for these guys. So these guys, okay, I'm getting distracted. Was not expecting these tunes, pleasantly surprised. Hey man, this is ideal code, true. We're doing permutations here. I'm kind of wanting to just write a Jai thing to convert an inherently recursive function call to a stack call. I bet I could do that. It might take me like 4 hours though. Actually, I bet it would. Maybe I shouldn't do that. Okay, 0, 1, 2, 0, 1, 3, 0, 2, 3, 1, 2, 3. And then, damn it, I keep typing fucking. Use it. Get this shit out of here. It's easier to like do it from scratch because then it's a pattern instead of trying to edit code. 0, 1, 2, 0, 1, 3, 0, 1, I. Okay, now, wait, yeah. Now, 0, 2, 3, 0, 2, I. Now, 1, 2, 3, 2, I. Did I miss anything? I feel like I did, no? 0, 2, 3, 0, 2, I. 1, 2, 3, 1, 2, I guess. Not. And then 2, 3, I. That's the last one. And now the 4 ones. Okay, how does this work? Am I missing some? I'm so fucking confused right now, man. 0, 1, 2, I, 0, 1, 3, I. Yeah, I'm not missing any. This is right. 0, 2, 3, I. 1, 2, 3, I. That's it, right? For permutations of 4. 0, 1, 2, 0, 1, 3, 0, 2, 3. Because the order of these guys shouldn't matter, so. And then 1, 2, 3. I guess that's it. Alright. We're fucking done. This is never gonna finish running. This is gonna run forever. So I think because these spheres are inherently, what's the word, like, the points lie on the bounds, right? So if you find a sphere that this is the whole bit of the logic. If you find a sphere that contains all points, it is instantly. No, that's not true. God damn it. You have to let the algorithm finish running. Oh no. So I'll have also smallest sphere radius float 32 max big sphere or 0. We'll do 0. Okay, so then if this sphere does not contain this point, you pop it or whatever the fuck. If the sphere doesn't contain the point, skip. Just basically not continue though. Wait, continue. Why the fuck is it continuing? If it does contain the point, continue. Oh, whoops. I read it wrong. Okay. I think so far this is good, right? And then that's all. When it reaches the end of the loop, meaning it. No, okay, in this case I can't break. I have to continue. How do I continue the while loop? You give it a label, right? I think this is how you do it in Jai. So instead of these breaks, all of these breaks go to continue sphere loop. I think that's okay to do. So meaning the sphere is no longer valid, create a new one, and continue at that guy. Okay, whoops, I hit my mic. I know I'm, oh, the smallest sphere thing. Okay, so now at this point, when you're down here, if your current sphere radius, if the smallest sphere radius is 0, or the current sphere radius is less than smallest sphere radius, this is actually never going to finish running ever. Ever, 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 ever. Maybe I should look at the Wikipedia article though, because I only looked at this thing, and this doesn't look right to me. I don't know if the Wikipedia article is the same, but I cannot possibly understand how this could ever work. Makes no fucking sense to me. You get into a situation where you don't have you can't return. Like, you will add more than 4 support points, I'm like 90% sure. And then you get down to 0 number of points, and now you're just fucked. Like, you can't decrease the num point count. You can't decrease support, like, it doesn't make sense. So, maybe I should read the Wikipedia article. Anyways, here's my code. Very cool. I'm gonna run it, I think. Hey, Eustace, how's it going? Allocation is the last of my worries now. Holy fuck. Maybe I should do something like this. Iterations remain. Iteration. Blank of blank. Iteration 0. Spheres count. Why is this a special color? Oh, because of this guy? I don't think that's how that works. Iterations of blank of blank. I don't want to run the code. I know it's not going to work. Load bounding sphere. Oh, I renamed it. What did I rename it to, though? Bounding shapes. How's it going, Eustace? Bounding shapes 84. Oh. This is not how you do this. Do you know how to do this, Eustace? Add a label to a while loop. Is it this? Oh, I guess it's that. Okay, never mind. Tree instance model is this. Create it with an AABB and a bounding sphere. Why is that not okay? Wait, what? You can do this? Yeah. You can add a label to a while loop, and then you can continue at it. So when it's different than breaking, right? So breaking will go out of this thing, but then this just skips all that. It's like almost a go-to, but loop-based. You can also do it for for loops, but the for loop label is inherently whatever your iterator variable is called. Kind of useful. A lot of times you write a loop and you're like, found is false for whatever, but this skips the found thing, because then if you pass the end of the loop, you've found it, right? So it's kind of just reduces some code. Why doesn't this work? AABB wanted a geometry given a type. Oh, I just didn't add the correct overrides. My bad. So this one. Can't this just call into this or no? Geometry instances. Oh, because it has a special cast. But it's the same size. And this array copies with T. I can call into this. Pretty sure. It still needs this though. It still needs a function call, right? Yeah. Alright, so I'll do the same thing. If you call into this guy, then actually... Wait a minute, I'm doing all this stuff wrong. You're gonna say return create... This thing doesn't even set the static data, even though it has instances. Whatever, it should. Model, static ABB is ABB, bounding sphere. Create the instance model. T, geometry, instance. Okay, wait, this is the same shit, right? Vertex iterator. Things are getting complicated. Geometry, instances, AABB, bounding sphere. Should upload. Okay, now my goal is... Yeah, now my goal is just use that. So you'll have to make a model matrix view. I will pass it into that one down there though. Create your model matrix view because it's the same size. Maybe I should assert that. Matrix 4 is size of this. That should be compile time, I think. Okay, so one more. Model matrix GPU geometry instances. There's probably a reason I couldn't do this before. I wonder what it is. I don't see what it could be though. And then same thing except AABB and bounding sphere. And this does the same shit, right? Copies the array with the type that is presumed to be correct, dynamic false, and then things, and then okay. Wanted 2, got 5. Wanted missing argument bounding sphere. Huh? It needs instances. Oh, the trees don't have bounding stuff. Okay. Just delete it. Instanced model. For blah blah blah. Given a matrix for one in a model matrix GPU given matrix for. This came from instance model 57. Did I not do the cast right? Oh, it's instanced GPU. It's the view. I'm not using the view. Now what? Get vertices. Thanks for the follow. One in a matrix 4 given a model matrix GPU. Oh. That's true, actually, yeah. Okay, so this method... this method kind of inherently cannot have this stuff. That's the difference between them. I guess you can provide it if you want. In this case, they would both just be empty because they don't exist. So it would just be this. So then this one has to be... God, this is confusing. Like that code. That code goes here. Vertex iterator, because you don't have it yet, and you have matrices of the geometry and the instances A, B, B. Okay, so that goes A, B, B, and bounding space. Okay, that should be right, and I'm kind of reusing all the methods. Model instances. What a matrix for? Oh my fucking god, bro, come on. That's true though. You just do model instances data. That'll be fine because this is the same thing. And then matrices. Fucking now what? Oh, I don't have block allocator? Guess I should. That's a new dependency. Woo! What's it called? Ah. Contains... This does have GIMath though, no? Oh my god. This doesn't have GIMath. Uh-oh. It does. Just not here. But it still doesn't like it. Because... what I thought was a sphere is a sphere entry. Okay, so we'll say sphere entry is pop that. Sphere is sphere entry. Sphere supports. Supports. Support. Counts. Sure, support points, whatever. Please fucking compile. Bounding shapes 55. Oh, that's not how this works. This is a create sphere function. Whoops. What am I doing? Also, whoops. Pop. Okay, yeah, what if you have none? Uh-oh. You can't return a pointer. I could return... I guess you inherently know something is valid by doing this because you're checking the count, so it's fine. Block memory. Block. What? Okay, what line was it? 234. Allocated memory. Model. There is no model. It is only geometry now. It compiles. Okay, so we're gonna sit here and oh. Uh-oh, that's really bad. Uh-oh. Oh, it's because I changed the data. Oh, this is okay. Okay, so basically I have to go into my files and delete all the serialized stuff because I didn't change the file, so it's not reloading, but all the serialized things are fucking dead. So we'll just delete the entire assets folder, I think. Wait, but what about fmod? Where's fmod live? I thought fmod was... Oh, it's in there. Shit. I can make a script. I might just make a script here. Script. Delete serialized geometries. Actually... Yeah, it'll be fine. Run. So, file list. How does this work? It's tprint maybe of something, slash something, back assets, and then file path, and then recursive true. I think. If the file is not in with FAT geom, skip, delete, file, delete, file. That's all, actually. That's all it is. Now, jai scripts, delete, serialized. Hope it doesn't go wrong. File list. Okay, we have to do some stuff. Import files. File utilities. Oh, import directory that. Is it called file? Fucking. Did it do it? Yep, all the geometries are gone. I guess I should print, right? Like, deleting geometry, deleting file. For future stuff. Alright, now, run the game. Now it's gonna take forever to fucking build.
Welcome to Fat Goblins.
It's actually... Huh? Oh no. Level man. Oh, the fat level is different. Okay, you know what? This script should be delete serialized. This is stupid as fuck, isn't it? It's like, this shouldn't be how it works. Okay. Don't need this script, actually. All that has to happen, the only thing that's preventing me from doing this otherwise is just deleting the folder is audio. So all I'm actually going to do this is kind of stupid. How should I do this? Asset loader. So my goal is all my raw assets are going to be in assets raw, and then all of the stuff that's loaded in the game is in assets when I'm done. So then the production build of the game, you just copy the assets folder and it's all like raw memory, like every single thing. So assets raw is no longer used ever. So that would imply fmod should live in assets raw actually. But so then you have to have a load serialized bank, which is gonna be weird as fuck. Bank. Give it a path. None of this. See, it doesn't even make sense. So it's not even load, it's like ensure, actually. That's probably all you do. I'll do all the rest of the stuff though. Yes. All of this. Assets raw. Whatever the fuck. Wait a minute. This is all I do for the path. Okay, this is a better example. Serialized path is get this path, but can I call it a fat bank? Even though it's... I should just call it a bank, right? I should just call it a bank. But I like fat bank. Okay, I'm calling it a fat bank. And then all you're actually going to do here... Uh-oh. This will work. Maybe. So load serialized. Let me see if I can use one of these methods. It checks the hash, right? Get the hash from the files. That's not that bad. A list of files. What does that guy do? Okay, that actually does stuff. So, all right. That's kind of what I'll do. So this will be the cache, hash, size, and success of dependencies. No. Of serialized path, which this probably has to be a two-string thing, no? Yes. But, let's see, get depths. This is already that. Okay, so path, that's, fuck, I'm so fucking confused. Okay, dep hash, dep size, dep success. Deps. So that one's deps, right? This one is a fixed string. So this one is a fixed array of a two string of this thing. Okay. If not, I guess I'll say should reload or something. Dep hash is not cache hash. They have to be the exact same thing. Or, well, like, they have to be the same thing and they have to be the same size and they have to have both worked. Okay, now if you should reload, we will copy file. Does that make sense? Is that all you do? It'll probably work. What is it? Source destination. Source path. Destination. Serialized path. I just don't know if this is going to override the file, but I think it will. That's probably all I do. Ensure serialized bank. And then it makes a fat bank. And then I guess you would need to give it back a string, right? Okay, I don't know. I think this works. So all we do now, this very nice call. That's it, except raw. I have lots of messages, hang on. Ensure, so okay, let me keep doing this. Ensure serialized bank, blah, blah, blah. I have to copy this stuff over. Actually, instead of copying it over, let's go to, I'm gonna delete the whole assets folder, right? So, whoops. We're gonna open my fmod thing, and then we're gonna change my build settings. Bank build output directory. Can I change the name of this? Like Fat Goblins. I prefer that. Assets raw. Okay, and then let me check the assets raw audio. Does it have an fmod folder? It does, with stuff in it. Called desktop. Called desktop. I don't think I would ever have a different bank. So in fact, let's actually delete that. Okay, I'll delete it in a second. Let's build this. Did it build? Yes, there's Fat Goblins. Now we'll delete. Oh, it's gone. Huh? Okay, anyways, so now I think I'm actually safe to just delete this entire folder and then rebuild every single thing in the game. I hope. Oh yeah. What am I supposed to do here? I guess I could t-print the string. I either t-print the string or I return a fixed string. Nothing else has to deal with this. It's a little bit tricky because this guy needs just straight up a string. It's kind of unfortunate. Do only read cache if needed. If should read, okay. I think I don't know. I think I'll return a fixed string. Fixed, because that's how everything else works so far. I think of 512, yep. So then return the serialized path no matter what. And then here, when you ensure the bank thing, you get the toString. Is that even okay to do? Like, it's not. Isn't this a small variable or whatever it's called? I don't know. I'll try it. I think it'll be okay. Weird shit's happening. Get hash from files. Is that private? Damn it. I think I would want to just reuse this though. So, no longer private. Not find specified path. Assets audio fmod desktop first fat bank. But why? Assets audio. Where is it? Where is it? Let me run it again and be sure it still crashes, which I think it will. Please crash. Okay, thank God. Okay, now says ensure. So you create the path and then you do the thing, and then if you should reload, which you should, copy. So I guess copying from blank to blank. What the fuck? Assets raw audio fmod desktop. That's the problem. I changed it. Whoops. It was totally a valid thing. It's called Fat Goblins.
Welcome to Fat Goblins.
Okay. It seems to be stuck on something. Cannot read. So it's going. Although the weird thing is, I'm pretty sure it printing all this could not read geometry. means it's loading geometries. But when it creates a geometry, it's supposed to create the sphere. Oh, there it goes. That was so incredibly fast. What? But see, okay, what about this? Could not read serialized glade blade hat. So then it should immediately go for the fallback. Class manager. Yeah, I guess, right? And then asset loader loads serialized geometry. So what happens is it loads the geometry, and let me be sure that's calling the function. Where the fuck is it? Okay, load geometry. So it does this stuff. Where does it set the AABB? When you create, okay, wait a minute. Ah, it does it separately. That's very not smart. Yeah, this is a very, very stupid way to do it. In fact, not doing this. Yep. This is OBJ though, but it's just so fucking dumb. So it's like here, if a geometry already exists when you're, I guess, right? No, I can do it afterwards. It's so much easier, right? Afterwards, just go through all your geometries. Yep. Geometry ABB is calculate ABB of geometry. That's all. Although that does not fix this one. Well, this guy gives you the AABB. I don't think I want to do it that way. How reliable is that? Oh no. I don't think it's reliable. Let's not do that. Okay, so in this situation, when you have your geometries, before you return them, I guess same thing. Okay, I guess I'm gonna delete this whole folder again, right? Because I'm allowed to do that now. Run again. Oh wait, what was the access violation? Bounding shapes. Oh, wait a minute. Iterator. Aw. And geometry. So basically, this isn't in the stack call or whatever, but it's get vertices of geometry is what probably what's crashing. Calculate AABB of that preserved faces is not known. Bounding shapes 194. That's just calculate AABB, right? Going through the vertex iterator. Okay. So this guy doesn't work. Uh-oh. Oh, this is probably, yeah, that's the problem. This, whoops. This has to be this. Boom, 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 boom. It was casting it to a vector 3 and then adding stuff. I need to add... Oh, wait, this one might be right. No, it's not. Using stride, it needs a float. Okay, I think this will fix it.
Welcome to Fat Goblins.
Where'd my music go? What the... that... My computer. It's like freezing my computer. I guess it's working really hard, maybe. Bounding sphere took... I cannot believe there is... Okay. There's no fucking way that bounding sphere function I just wrote takes less than a millisecond. No fucking way. Something's wrong. Vertex iterator. I'm gonna be working on this a lot today. Not looking forward to that. This is still wrong, huh? Stride. Go through the geometry indices. Vertices data, which is float, plus this index times stride. Cast that down to vector 3. So that gives you the float offset based on the stride. And the stride, for example, for a vector 3 is 3. So that is the number of floats. That is a float. Well, shit, this looks right so far. Oh wait, but that's... whoopsie. That was probably the problem, right? Because it was giving you a pointer. God, I'm dumb. Oh no, I was dereferencing it. Maybe this is wrong. Vertices count over stride. So that's basically the number of vertices minus 1. Flags, and if it's a pointer, you get wrapper geometry vertices data plus I times stride. I don't know. This looks right. Oh, it crashed because of a division by 0 error. Oh, wait, what? It's not a memory issue like I thought. Wait, but what the fuck could it... What? It's saying it crashed... Oh, stride for something is 0? Is that what it's saying? 3. Let me close my window while it does this.
Welcome to
Crashed stride 0. What the fuck could have a stride of 0? It's coming from this. Load the OBJ. It thinks this OBJ, when it loads it, has a stride of 0. How? Fucking what? Does it already exist and it's loading it serialized? Assets, goblin body crystals. Does not exist. Does it exist here? Goblin body crystals OBJ. I guess this has to do with this new thing I just did with specifically OBJ loading, where when it's done, oh, this is my fault. You have to do ABB bounding spheres after attributes. So GLB might have the same problem? No. Whoops. Okay, well that fixed that. I can get rid of the stride check of that 4 expansion. Continue. Serialize everything.
Welcome to Fat Goblins.
Calculate bounding. I cannot believe this. It's gonna be not right. Oh well. Alright. Now what? Crash because of a divide by 0. Again. Sphere points count. How could that be a divide by 0? Which one is it? It must be this. Don't really see anything else that could be dividing by 0 here. But that definitely should not happen. Maybe, oh, it's because this is an iterator. Whoops. How is it even getting into there then? It was allowing the iterator to be assumed as an array. That's so weird. That's kind of a Jai bug, but it's kind of my fault also. So I don't know if I should report that. Can I check other things for get vertices? Iterator. Yeah, so stuff like this. Copy vertices. Wait, no, these are expected to be iterators, huh? Okay. That's also iterator. Alright, I guess that's so far everything.
Welcome to Fat Goblins.
Crash. Still you. 0.0. How? Okay, where did it come from? That's a better question. Oh, hang on. So, oh, that is supposed to be an fucking iterator. And then you add it into final vertices, and you return that, and somehow magically it's 0. Shouldn't this be temper allocated? And then that just I don't know, man. I don't know how this could be. It's weird as fuck. I guess I could also check. sphere vertices. So I would want to also, I don't want to do this. I'd rather do get them right there. Vertex. Let's see if it's getting anything at all. It's still possible to think that my method is bad. Icosphere. That's a... maybe... I think it is a geometry. I don't know. Whatever. I don't know if it's a geometry or a model.
Welcome to Fat Goblins.
Crash. Icosphere, something, sphere vertices empty. Alright. Can I dereference that? Probably not, because it is going to be a model, right? Pretty sure it's a geometry. Never mind. Geometry, so actually indices count, icosphere vertices count. I'm very confused. So one more thing. Stride. Get the stride of your icosphere. I think I might have to end my stream really, really early today, unfortunately. Might have to go. In fact, I'm pretty sure I have to go. Get the stride. I'm gonna fix this real quick though. Get the stride of the icosphere. Wanted a pixel. What? Oh, of attributes. Shit, unlucky. That should work though. Oh, it's not for here. Okay, it's not get stride for this guy. Wait a minute. Get attribute stride. There you go.
Welcome to Fat Goblins.
Icosphere, it has a bunch of shit. Okay, so this means this method's not working. I guess I want to see what this is. Maybe it's just somehow completely returning the wrong thing? It's supposed to be returning an iterator.
Welcome to Fat Goblins.
Whoops. It is get spheres returns something. I think this is a struct that is holding my geometry, which is correct if that's what it is. And I think that's what it is. Well, wrapper geometry indices. I'm not preserving faces, so it's this one. So let's check some stuff, right? Wrapper geometry vertices count and stride.
Welcome to Fat Goblins.
It is 486 and 3. That sounds right. So this guy would be going from 0 to... oh. Wait, no, this is still right. Yeah, this guy would be going from 0... I'm still fucking confused. To like 150. Print. I. If it's a pointer, it's this. If it's not a pointer, it's this. That all should be right. Index is I. That should be right. What the fuck? Is it somehow... no, that's not it. it. I mean, let's try again then. Ignore all this stuff. The only time this matters is when it crashes.
Welcome to Fat Goblins.
It's gonna spam the shit out of it. Spam, spam, spam. While it's doing this, let me look at the code. Yeah, I mean, nothing else. It's not even printing vertex, right? It's just saying get vertices of icosphere. And then it's not returning any vertices, so the final vertices is 0, and then it returns that. Yeah, I don't know how long this is going to take. Maybe printing it was a mistake. Zero to vertices count overstride. Yeah, I don't fucking know. What could be wrong, man? This all is totally right looking to me. Because even I printed those two things, it's 486 and 3. So at the very least, this should be doing it like 150 times, which is right for an icosphere. And then it assigns your iterator thing in the expand macro. That's right. Oh, it crashed, right? Okay. It did actually do it. It did it. What? I am more confused now than I have ever been. Get spheres, icosphere, and then it goes down here, and then at the very end of it. So it never said vertex, by the way. Oh my god, I'm so fucking dumb. This shouldn't be allowed. I didn't insert the body. Oh my god, you shouldn't be allowed to do that. I mean, I guess you should be, actually. You should be. But god, am I fucking dumb. Oh, man. Okay, did I not do that to another one of them? This isn't the only thing that has this 4 expansion. Instance model has it. That one has body insert. That's not the new one, though. The new one is get vertices. Instance model vertices. That one has it. Okay. Fuck. Fuck. Get rid of all this shit, because it'll work now. It'll work now. I'm sure something else will crash, and then I gotta go. Let me start trying to find someone to host. Damn, I guess I'll just work off stream tonight.
Welcome to Fat Goblins.
Might as well host Custa, I think. Or Non-Co's. I haven't gotten the chance to host her, because she hosted me a couple times. I should host her. C! Yay, she's doing C. That's good. Hey, wait, it loaded. The fuck? Okay. Things are clearly not working yet. Also, okay, the bounding sphere is a single point, you can tell, right? Because the thing has to get entirely, the center of the model has to get inside the frustum before it renders, like that. So, yeah. Okay, let me start hosting non-codes. I gotta go. Unlucky, but so all the stuff works. The algorithm I'm working on does not work. If I'm back early enough, I might stream tonight. I might flip my schedule today. We'll see. Because I want to kind of do... I think the perfectly accurate bounding sphere algorithm and ON time algorithm thing is like actually really interesting to me. So I kind of... That's the type of thing I would want to do on stream, but... Alright, I gotta go, unfortunately. Might be back in a few hours or 5 hours or something. I don't know. Thanks for the follow. Yeah, thanks for hanging out, guys. If I'm not back now, shit, I do have to submit my demo today. If I'm not back tonight, I might be back. I will be back Monday, so that's my plan. Bye-bye. Thanks for watching. Yeah, hopefully I can start again tonight. See ya.